Hello and happy Wednesday from all of us here at Professional Dairy Producers. I'm Shelley O'Leary and I am excited to bring to you today's Dairy Signal episode. We're going to be chatting with Sherry Schwert, Ag Water Quality Outreach Specialist with the UW Extension, on the topic of unraveling phosphorus. She has a lot to teach us about how we can take good care of our lands. And I look forward to digging in a little more deeply with her on that. Before we get started on the topic, I do have a few things that I'd like to take care of first. First of which is I want to extend to all of our national sponsors a hearty thank you for all their support to the professional dairy producers and our membership all year round. Without them, bringing content like the Dairy Signal to you would not be possible. So we thank all of our national sponsors. Uh, Also, I have a couple of fun things that I'd like to share with our listeners. We're going to go back in time just a little bit and talk about today in history. Today being May 28th, some of you might be familiar with the name Ian Fleming. He was born on this day in 1908. If you aren't familiar with him, if I were to say 007 and James Bond, that probably conjures up some imagery in your mind. Ian Fleming was the man who created the James Bond character. And interestingly, a lot of the James Bond motifs and themes, Ian Fleming drew directly from his own life. Mr. Fleming was quite the character. And in fact, I'm going to look at my notes here. So pardon me as I look away from the camera. He served as an officer in Britain's Royal Navy. He was a Naval Intelligence Department member. And in real life, he himself devised a number of wartime schemes that were worthy of his own James Bond character. In fact, some of them were successful and others were deemed too wild to carry out. And here's a fun fact. I did not know this about Sir Fleming, but he's also the author of Chitty Chitty Bang Bang. That was a children's book, the only one he ever wrote. And what a classic. If you're only going to do one thing, do it right. Yeah? So that's today in history. Let me not forget to remind everybody that today is National Burger Day. It's National Beef Month here in the month of May, and we just have a couple days left. So even if it's raining where you live, you want to make time to get you a burger. In fact, I see that Wendy's and Burger King and a couple of other places are offering some pretty great deals on burgers if you feel like the drive-through is going to fit your schedule better than firing up the grill today. Or maybe it's going to suit the weather pattern better than firing up the grill today. Okay, I want to turn a corner a little bit and bring to the attention of all of our listeners a couple of PDP programs that are just around the corner and that we have registration open for. The first is our international tour, February of 2026 to New Zealand. If you haven't already registered for the trip, you should do that right away. Seats are very limited, and when they're gone, they're gone. We can't carve new spots on the bus. So to find more information about the international trip to New Zealand, there'll be fun. There'll be some dairy tours and some other tours built in there as well. So it'll also be educational. Go to www.pdpw.org and scroll down to find our upcoming programs, and you can learn more about our New Zealand trip. And while you're looking at our upcoming programs, I invite you to also check out our July 22 Accelerate program. This is a program that PDP has designed specifically for college-age summer interns in the agricultural sector. The cool thing about this program is it's designed not only to benefit the summer interns that attend, It's also designed to give a boost to the employers, the intern supervisors who send their interns to this program, because it presents a one-day opportunity for their students to learn at a level that many organizations and most standard internship programs don't have access to. So check out PDP Accelerate. That program is happening July 22 in Madison, Wisconsin. And you can also check that out on our upcoming programs on our website. And you can register your interns or find out more information about that already today. Okay, as we move forward, I want to give a shout out about our DACE, our Dairy Advanced Continuing Education credits. And anybody listening to the episodes of Dairy Signal or attending other PDP or other programs can qualify for continuing education credits. And if you're listening to this episode or any Dairy Signal episode and you want to get credit for the time that you spent, then watch for a pop-up quiz at the end of today's segment. You'll answer a couple of very easy questions if you've been paying attention, and then you'll be set. We'll make sure that you get the continuing education credits that are coming to you. Okay, as I introduce Sherry, or just right before, I want to remind everybody who's listening live that you can make this program your own. If you're viewing today's episode from a computer, from a desktop computer, then you'll see the slido.com resource to the right of your screen. On the other hand, if you're tuning in today on a mobile device, then just scroll down and you'll find the Slido prompt there where you can ask a question and enter it, and then I'll see it pop up here magically on my screen, and then I'll be able to ask that question of our presenter today. So here we go. Let's dive right into our topic today, unraveling phosphorus. I introduce to you Sherry Schwert, Ag Water Quality Research or Outreach Specialist with the UW Extension. And I am going to ask you, Sherry, to briefly introduce yourself and how you got involved in this in today's subject matter. And you can take it away. Carry on.
Thanks so much, Shelley. Hi, everyone. Thanks so much for having me on the Dairy Signal again. So excited to be back. So yes, I'm an Ag Water Quality Outreach Specialist with the University of Wisconsin, Madison Extension, and I cover the Southwest region of Wisconsin. We are regional outreach specialists. So if you're not in the Southwest, there is a different Ag Water Quality Outreach specialist for your area. But we also specialize in a few topics, and phosphorus happens to be one of mine, along with extreme weather and the consequences of that, and the benefits of edge of field practices and how they can influence water quality. Phosphorus is one of my topics because my team, as you'll learn about now, or shortly, has a soil test phosphorus project, or STP project, that we conduct every year since 2023. And it's one of the only opportunities I get in the year to do any sort of field work. So that's one reason that I became interested in the project, but also because, once again, as we'll learn, phosphorus is a really big issue and a really big part of the conversation about ag water quality here in Wisconsin. Myself, I've been in the position since 2023 and have been really enjoying my time so far working with farmers in the driftless region, which is also where I'm from. So let's dive in. The catchy title for this presentation is Unraveling Phosphorus. And I gave this presentation at the PDP Business Conference. If any of you happened to be at that conference, you might get a repeat, but some of the information has been updated and changed since then as well. So the less catchy but more descriptive title is Soil Test Phosphorus and Stacking Practices to Reduce Loss to Surface Water. How surface concentration or phosphorus stratification occurs and what we can do about it. In this presentation today, we're going to discuss why we're talking about phosphorus, why phosphorus is important to talk about with water quality. I'm going to talk about what phosphorus stratification is. Hopefully you'll have a good definition of that to walk away with by the end of this presentation, as well as an understanding of how it occurs in agriculture systems. I'm going to discuss the STP project that my team is in charge of right now and potentially how you could join. We're going to go through a field phosphorus balance and a couple different field phosphorus budgets, just something to keep in mind when considering phosphorus stratification and phosphorus loss. And finally, I'm going to end with suggestions for phosphorus drawdown based on what we currently know, if that is something that is necessary for your field and for your farm. So to start with, why are we talking about phosphorus? Well, on the right here, you can see a map of the impaired waters, surface waters of Wisconsin. 1,265 waters are listed as impaired, given by the 303D list. And those waters, not necessarily, we're not just talking about an entire river that would be listed as one water. A listing can be a stretch of a river, but it also includes lakes, reservoirs, and impoundments. Nearly 50% of those 1,265 listed waters have phosphorus as at least one contaminant. They may have other contaminants as well, but nearly 50% do have excess phosphorus. The good news is that in 2024, 38 listings were removed because they attained water quality standards. And many of those 38 were removed because they no longer had excess phosphorus. The bad news is that 69 new listings were added. And we'll see some of those are in remediation already, but the same goes for the proportion of listings that were added, which is that many of them were added because of excess phosphorus. So of the new listings, 22 of those were for just straight excess phosphorus, but 14 of those that were added for excess phosphorus are in either a 9 key element plan or have a TMDL plan, which means that the watershed community is aware of them and working on remediation for those listings already. As you can see, there are obviously other contaminants, other issues listed here, but phosphorus is by far and away the largest proportion. Of the listing removals, once again, the largest proportion was for phosphorus. And I would like to note that the second largest proportion was for excess algae, which is pretty related to phosphorus if we think about it a little bit. But it's good to know that of these listings being removed, we are seeing improvements in excess phosphorus across the state as well. It's a little bit of a 2 steps forward, 2 steps back, do-si-do situation, right? Which is why I'm here talking to you about it today. Before we dive into the next slide and the next section, I do just want to connect these impairments that we see to ag water quality and agriculture. There are natural environments that can be sources of phosphorus, including forests and native prairie systems. We know that CRP land even can cause phosphorus runoff. But as I've shown, the majority of water bodies in Wisconsin's impaired waters list are a result of excess phosphorus. And since agriculture land composes the majority of the land use of these watersheds, this is where there are opportunities to make water quality improvements. And because agriculture uses phosphorus regularly, that means there is an opportunity for change all of the time, every year. So let's talk a little bit about phosphorus stratification or surface phosphorus concentration. So this is a hypothetical situation here. Field A and Field B, the numbers that you see are not based on, real tests where we measured the phosphorus in every inch of a soil column. But this is an example of how the stratification occurs. So in this hypothetical situation, I went out to Field A and Field B, and I took a 6-inch sample core, and I sent it into the soil lab, and the soil lab came back with an average STP, or soil test phosphorus, of 30 parts per million. 30 parts per million, that's pretty average. That's not really a water quality concern. That'll grow you, decent crops for the most part. And for field B, that's a decent measure of what we see there. 40 parts per million in the top 1 inch, 23 parts per million in the bottom 1 inch. The plants are going to get a pretty consistent access to phosphorus there. So why is field B, more even like that as we go down the column? Well, for starters, field B has, let's say it has conventional tillage. That soil is getting turned over regularly. And there's manure application, but it's incorporated or potentially it's injected. So the phosphorus sources that are coming in from the top are also getting mixed in with the rest. For example, if you got a parfait at a Quick Trip has those delicious strawberry parfaits. There's granola at the top, there's strawberries, there's yogurt. If you take your spoon and you dig it all the way in down the bottom and you stir it all around, then the granola and the strawberries get mixed in. That's the same that's happening with the phosphorus here. Because it's conventionally tilled, that phosphorus is mixing. On the other hand, in field A, we can see that we are seeing a much higher amount of phosphorus in that top 1 inch, 70 parts per million, in fact, if we were to break that down. And 70 parts per million is approaching a water quality concern, just in the amount itself. But especially because it's in that top 1 to 2 inches, that means it's also more likely to interact with precipitation and become a runoff event. In field A, let's say that this is in the driftless area where I work. So this field is no-tilled because of a concern for soil erosion and soil loss. And it's a dairy, so they do a surface applied manure, but they don't incorporate it because they have these no-till goals. So that parfait, the granola and the strawberries and the yogurt, are staying separate. You're not digging your spoon in there and turning it up. So the phosphorus stays at the top because that's where the sources of phosphorus are coming in. And unlike nitrogen or nitrate, the phosphorus does not readily move down the column on its own. So you wind up with 70 parts per million in the top 1 inch and only 10 parts per million in the bottom inch there. So that's phosphorus stratification and how that occurs. If you walk away thinking of it as a parfait, that's a great memory tool. So our sources of phosphorus, there's 3 main ones that I want you to think about. And one of them I already mentioned, manure. Manure is a source for phosphorus and a legacy source for phosphorus in Wisconsin. Fertilizer, of course, is a source for phosphorus. That is an input that goes into the field maybe every year. Crop residue is one we maybe don't talk about as much, but as crops pull up the phosphorus that they need to grow, and then let's say you're harvesting corn grain, the stover that's left on the field, that also has phosphorus in it. And as that crop residue decays, it releases that phosphorus back into the soil, keeping it in the system. There is sort of a fourth source of phosphorus that's a source in the same way that the letter Y is both a vowel and a consonant. It can be a source for phosphorus and important to think about in inputs, but what I'm talking about is legacy phosphorus in the soil. So if you're looking at your inputs, you may have to think about legacy phosphorus as a source because you yourself didn't maybe put it there. But it originally came from one of these 3 sources, manure, crop residue, or fertilizer, which is why it's only sort of a source, but it's something to think about. The point is that with all of these sources, if unincorporated, all of them can cause an increase in phosphorus at the very surface of the soil, where it is particularly vulnerable to loss by a runoff. On the right here, you can see a stream that has obviously taken in some soil loss in runoff, fairly turbid stream there. And phosphorus, just as a side note, can be lost sort of one of 2 ways. It can be lost as particulate phosphorus, which is potentially what you'd see here. Particulate phosphorus moves when soil moves, but it can also be lost as dissolved phosphorus, which is a little bit sneaky, a little bit pernicious, because it can mean that you can maybe see runoff off the field, but it's clear, it's not taking soil with it, but it can be taking phosphorus with it in the dissolved form. So this phosphorus issue is why my team is conducting this STP, soil test phosphorus project, and has been doing so for 2 years and will continue to do so. Our goal is to collect high quality on-farm data to help improve our understanding on how soil health practices impact soil phosphorus stratification across the state. Our other goal is also to deliver outreach on this topic to either introduce phosphorus stratification to people who have not heard of it before, or to deepen people's understanding and nuance by learning about this information as we get it as well. And that's what I'm doing today, delivering outreach. So the farms that we include are majority no-till because when you're not mixing the soil, that is when you tend to have this phosphorus stratification. But we do include some other farm management styles as well. Ag water quality staff, like myself, take samples in the fall before nutrient application. Like I said, that's one of the only times of the year I get to go out on the field. So it's one of my favorite times of year. And when we're out there, we separate the top 2 inches of a standard 6-inch soil core from the bottom 4 inches. So that way we can see if there's a difference from the top to the bottom to determine if there's stratification. On the right, you can see the counties in red are counties that have had farms included in the STP project so far. So 30 counties, 80 farms, and 220 fields so far. So 224 data points included. If you live or manage agriculture land in one of the counties that is not colored in red, and by the end of this presentation, being in the STP project is something that would interest you, please, you can reach out to me or to your regional ag water quality outreach specialist, or we have a couple of other ways that you can get involved. And yeah, we would love to come out to your farm and include you in the project. Oops. So on the right, you can see this is a picture from my field work last fall of a field in the driftless region. So we take the results, we take the samples, we send them into the soil lab, and the results are shared with farmers after they answer a detailed field and farm history survey that we send them. That includes things like tillage history, cover crop use and percent cover of that cover crop, the general crop rotation, manure use method and type, as well as fertilizer method and type. And we're asking these detailed questions because we're not just collecting the sort of bare bones data of parts per million of phosphorus, but we also want to know how is phosphorus stratification affected by these different management pieces here. After that, farmers receive a handout placing their results in context with statewide results. An aside, they also get results for pH, organic matter, potassium, calcium, and magnesium. So you're getting a fairly good laundry list of results in this project. But one of the things they get that I think is really neat is this graph that shows their results with everybody else's from the last 2 years of data. So this is an anonymized version of the graph. If you were a farmer and you got this back, your 3 fields in each of these clusters would be called out with the exact numbers, the exact data points from your fields. But real quick, just to understand it, the top cluster of data points is the soil test phosphorus from the top 2 inches that we collected. So that one bucket, right, that has all of the top 2 inches. And then the bottom is the standard 0 to 6 inch core. So you can see that if these farmers are just measuring the 0 to 6 inch overall, let's say on average, they would get around 30 parts per million. But when you actually look at the top 2 inches, which is at a higher risk for loss, the median's much higher at 50 parts per million. As well as, so the red dots represent data points that are above 80 parts per million, which is a water quality concern. And there are more dots, right, in the top cluster, more red dots in the top cluster than there are in the bottom one. So a field that maybe a farmer wouldn't necessarily be worried about could actually be in that water quality concern if we just look at the top 2 inches. We'll come back to this graph and discuss it a little more in a little more detail in a minute. Before we do that, I want to go over this idea of a phosphorus budget for a field. So this doesn't have like actual numbers on it. This is more of a thought process to take into account if phosphorus is a concern for you. So this is an example of a field where the inputs are greater than the outputs. And this is potentially, what we are seeing in this STP project is that on average in those top 2 inches, there's more phosphorus coming in than there is going back out. So you're getting a phosphorus buildup over time. We discussed the sources. So phosphorus is coming into that field in the form of fertilizer, manure. It's getting taken back out in basically the only way the phosphorus leaves, which is via the crop itself. And then maybe this is a winter killed cover crop situation. So the farmers planted a cover crop, but because it is winter killed, the phosphorus that crop took up just ends up back in the system anyway. So it's not truly leaving the field. This could be a field with surface manure application and, like I say, a winter killed or maybe no cover crop, or it could be a field with a long history of manure application and no-till. So you're winding up with some of that legacy phosphorus source. Like I say, pretty much the only way phosphorus leaves the field is through organic matter, through the crop leaving the field. Can also, of course, be lost via runoff. This is a field, an example of a budget where the inputs equal the outputs. Potentially the fertilizer or manure added has been reduced. So the amount of P going into the system has been reduced. But also the amount of phosphorus going back out has been increased because this farmer has included a rotation where they are planting a winter hardy cover crop that is harvested. And that harvesting takes that phosphorus that was pulled up by that cover crop off of the field, removing it from the system. So let's say you find yourself in a situation where you have legacy phosphorus or you know that you have more phosphorus than what the crop needs and you're worried about risk of loss via runoff. So that's when you're going to need to look at a budget that is what we call phosphorus drawdown. So you are essentially mining the soil for phosphorus. You are taking out more than what you are putting in. So in this field, the inputs are lower than the outputs. And over time, phosphorus will be drawn down in the soil, thus phosphorus drawdown. Let's say, in this case, manure is injected at low rates. They included a rotation of a crop like corn silage, which in itself doesn't necessarily take out more phosphorus from the field, but because you are removing almost the entire plant and leaving very little crop residue on the field, you are removing lots of phosphorus from that field. And maybe you're including that winter hardy cover crop of a triticale or a rye that is harvested and removed. So you are pulling out more phosphorus than you are putting in. It's important to note that some phosphorus may still be lost in this system, especially if you're dealing with something like channelized erosion. So you're losing a little bit of soil because of that. So some phosphorus may still be lost, but overall, this phosphorus drawdown is going to be a way to reduce your risk of phosphorus loss via runoff and reduce water quality concerns. So like I said, we're going to come back to this graph. So when we're talking about these red dots that are water quality concern, that is where you're maybe going to want to be looking at developing a budget for your field that is a phosphorus drawdown, where your outputs are going to be greater than your inputs. But you're not going to be able to see if that is an issue in your top 2 inches unless you go out of your way to take a non-standard soil sample of dividing it either down the middle or the top 2 from the bottom 4 and getting that tested to see if this is a problem. Because otherwise, you're going to take that 6-inch soil core, you're going to get that median of 30 parts per million, and you're going to be like, okay, that's great. Yep, all set. Whereas on the other hand, you may actually have more phosphorus than, if you have 50 parts per million, for example, in that top 2 inches, that might be a question where this crop, the crop that you're growing, is not going to respond to the addition of more phosphorus. So adding more phosphorus on top of that, not really going to help the crop and is going to increase the phosphorus in the top 2 inches into the excessively higher water quality concern area. So if you, on your farm or a farm you manage, want to look for this issue, your first step is to test the top 1 to 2 inches. So you're going to go out there with your 2 buckets, like I did. You're going to separate the core as you go. Once you get those results back, if it is higher than what is recommended, than what you would like to see in your field, you're concerned about phosphorus loss, consider reducing your inputs. If you're putting in corn starter, consider using a starter that does not have phosphorus in it. Because if you have 50 parts per million, 60 parts per million, 70 parts per million, the crop is not going to respond to the addition of more phosphorus. So consider that you may not need to be paying for that phosphorus in that starter. Or if possible, switch to a low disturbance injection if that works for your system. You can also, always want to give options, always want to give layers. Maybe you can introduce a rotation, introduce into your rotation an overwintering cover crop like a triticale or a rye. But then the key is that you have to harvest it to actually get that phosphorus off the field. If you're planting in the overwintering cover crop, but then you're burning it down and planting into it, that phosphorus is going to stay in the system. It's not going to count as an output unless you remove it from the field. I always like to end with this sort of pyramid idea so that I can talk about stacking practices. Stacking practices is something that myself and other members of the ag water quality team really recommend as stacking or layering as a way to address lots of different water quality concerns. In this case, we're talking about phosphorus loss, but different conservation practices can have different goals. A vegetated buffer has a different goal from a cover crop, which has a different goal from grade stabilization structures. So like I said, I work in the driftless region. Having a no-till system to improve outcomes for soil loss is the right choice. If you're farming on steeper grades, no-till is a recommended practice. I'm not here to tell you to till up all of your no-till fields in order to mix the phosphorus in. But if you're seeing phosphorus stratification, maybe on top of that no-till, you're introducing an overwintering cover crop or vegetated buffers to help prevent dissolved phosphorus and phosphorus losses. And maybe on top of that, you have a goal on the side of improving wildlife habitat or improving pollinator habitat. So you introduce a native prairie strip, something like that. But stacking and layering these practices means that your field has a higher ability to handle extreme weather and still not lose those valuable nutrients and our valuable soil. So that was a lot of information, but I hope that I've either introduced a new topic for you or introduced some nuance into a topic that you already understand, and I'm happy to answer some questions.
All right, Sherry, thank you for all that information. Today's farmers are hearing regularly about the nutrients that they need to remove from their field or add to their field, and it can be a lot to understand and try and incorporate in and amongst all the other things that dairy producers have to be managing on modern dairies today. It reminds me of the reason why, shameless plug here, the reason why the membership of professional dairy producers initiated our Your Farm, Your Footprint sustainability initiative. That particular project has to do with carbon footprint and helping dairy producers understand how they can manage their carbon footprint and what steps they can take on the farm to lower their impact in that regard and to continue to do the kinds of practices that are working and benefiting them. So we get to hear a lot about the impact of carbon, be that good or bad, and the issue of phosphorus is as important. I know that you would agree. So if I put my gardener hat on, I have questions like, well, how do I know if on my particular farm I should be sampling for phosphorus stratification? Maybe this is a super elementary question, but can you tell us, Sherry, what are some of the visual signs? What are some of the symptoms? What am I seeing out in my field or in the waterways around my fields that will indicate to me before I even get the soil sample plug out into the soil? What are the signs that I should be looking for that would be a red flag? Like, hey, potential problem here.
Yeah, I can think of a couple of different things. I think potentially if you do have waters included in the farm, especially slower moving waters, maybe an impoundment or a pond, if you're seeing excess algae in those ponds, excess algae is the limiting resource for algae in Wisconsin is phosphorus. So if we're seeing algae, that means we're having excess phosphorus issues. I think another way to think about it could be, I mean, if you're seeing soil loss, that means potentially there's particulate phosphorus going with that. So that can be a key marker, although if you may see soil loss without having excess phosphorus. I think another source, another way to think about it is that you could run a little experiment. Let's say one year you add more phosphorus in your starter or less on different fields. And if you see essentially the same crop yields from, excuse me, from all of those fields, that would imply that phosphorus is not a limiting resource for those fields. You have enough for the crop to be growing in all three of those. And so maybe reducing the phosphorus overall could be an option. But that could be a sign, is that if you don't see a yield change with a phosphorus addition change, then that probably means you have excess phosphorus.
And overall, what would you say that the common consumer perception is about phosphorus? I recognize that's a question that you would have to speculate on, but when I'm out and about with non-agricultural people, I don't hear a whole lot of them talking about, oh, phosphorus, like is the case with carbon. Uh, Talk a little bit about that. Is that even important? How is that relevant to the way we manage our dairies?
Sure. Well, I think that potentially, right, in speculation, one reason we maybe don't hear the everyday consumer talk as much about phosphorus as we would about carbon or maybe about nitrogen, um, is because nitrate is an issue that affects groundwater, that affects drinking water. And carbon is something that's heavily connected with climate change and everything that goes along with that. Phosphorus affects surface waters. And so that means that unless you are concerned deeply with surface water source, say because of drinking water or because of recreation, which is much more likely in Wisconsin, as most of our drinking water comes from groundwater, not from surface water, um, it might not be on your radar. So it's going to affect our aquatic ecosystems and affect the organisms that live in those systems. Um, but it's not going to affect humans on quite a deep a level as being worried about your drinking water. And so I think that potentially that's one reason why we don't see the everyday consumer talking about phosphorus the same way.
Yeah. You mentioned algae blooms, and boy, whenever I see a pond or a part of a lake covered with algae, I think, oh man, there's some water I don't ever want to swim in, and I wouldn't want my dog swimming in that either. So I think sometimes if it's not highly visible or talked about a lot in our news feeds, then the average, quote unquote, average consumer doesn't necessarily recognize that it's even something to contend with. So
Yeah.
good answers there. You mentioned that another area of interest for you is extreme weather. What are some of the ways that extreme weather swings or incidences play a role in phosphorus stratification and the levels of phosphorus that either remain in the field or that make their way to surface water, if at all?
Sure. I mean, extreme weather affects ag water quality by, introducing these rain events that our farming systems are, somewhat made to handle, but also somewhat not, right? When we in Southwest Wisconsin get 2, 3, 4 inches or more in one rain event, we're talking about levels of precipitation that are almost guaranteed to cause a runoff event on a field, no matter what practices that farmer has put into place. So that is why I like to talk about extreme weather, is because when we get those events, it kind of overcomes a lot of our conservation practices, because it's just so powerful. And that affects phosphorus because it is one of those nutrients that we see in the soil. And like I talked about, if we're seeing that phosphorus stratification in those top 1 to 2 inches, that, if you have heavy rain events, those 1 to 2 inches are pretty important. If there is excess phosphorus in those top 1 to 2 inches, it's much, much more likely to cause a runoff event during that extreme weather.
As part of your presentation, Sherry, you talked about how farmers could get involved in your STP project, your soil test phosphorus project. So I know you've already mentioned it, but I think it's worth mentioning again. If I'm listening from Marathon County or Forest County or out in the northeastern part of the state where there's karst and bedrock soils, what do I do to talk to somebody so I can get involved in your STP project?
Yeah. So yeah, if you I gave you some options to sort of test on your own, but if you want to be a part of the STP project, which we would love, yeah, you can get on. There's a couple options. You can get on the UW Extension directory and you can find your regional ag water quality outreach specialist. There is one that covers your area, I guarantee. Or and you can reach out to them, or you can go to the ag water quality page, the University Extension ag water quality page, which for me comes up on Google just when I type in ag water quality. But that's probably because I've searched it a bunch. So you might have to type in ag water quality Wisconsin Extension. And if you go to a header there that covers phosphorus and soil loss, there is an interest form where you can input your information. It'll send an email to sort of all of our emails, and you'll be able to get a hold of someone. And this is sampling that happens in the fall. So it would just be a question of getting in contact so you can let us know when your crop is off, but before you apply any nutrients in the fall, so that we can come out and get those soil samples. And then being willing to answer our detailed history, like I said, which does take a few minutes.
But that's a pretty critical part of the whole piece.
Absolutely, yes. And know that we're a little bit hardline about that. We will not send you your results until you fill out that field history, because that is a big part of the value for us.
Yeah. Well, good inputs into the system means good feedback coming out, right?
Absolutely, absolutely.
Yeah. Okay, so at the top of your portion of the program, Sherry, one of the first resources you shared in your slideshow was that map of impaired water listings. And of course, it was up there and then gone. I am kind of a geek when it comes to maps, and I would just love to study it and take a closer look at it and see how that fits in relative to the areas, the geographical areas that I would be interested in. Is that available? And this is kind of a two-part question. Is that specific resource available somewhere? And what other resources, you just mentioned a couple, are available for people who want to take time on their own to really just kind of geek out on how they can learn about this whole topic of phosphorus and getting it off the field, not just to bring it back in the winter kill situation. Talk a little bit about where I can find some of those resources to study on my own.
Yeah, so the map was created by the Wisconsin Department of Natural Resources, which is the keeper of Wisconsin's 303D list. And the 303D list is called that because that is the statute that mandates that the federal EPA collect this impaired water data. And the federal EPA gets that list from the Wisconsin DNR, which does the collecting for Wisconsin. So you can view not only that map of the impaired waters in Wisconsin, but you can also view the map showing which waters have been removed and added in the 2024 303D list. And that list is updated every couple of years, by the way. So if you go to the Wisconsin Department of Natural Resources website, you should eventually be able to navigate to the impaired waters list. But yeah, if you Google some combination of 303D impaired waters DNR, that'll get you sort of the landing page there, where you can see the maps and also read how that data is collected, and yeah, the details of what changes they see from each report that they have done. Other resources to talk about phosphorus. I mean, I have to plug the Ag Water Quality website, which has lots of different articles and videos talking about phosphorus and soil loss in Wisconsin. And as we continue our STP project, our resources just continue to build every year. So those will continue to build. And beyond that, I think that there are some for producer-led watershed groups that are addressing this problem head on by doing some of their own testing, even. So, maybe check in with your producer-led watershed group if you have one in your region and see if that's something that they're talking about there.
Excellent. Those producer-led watershed groups really have an impact. And the
Absolutely.
great thing is producers that are involved have an opportunity to bring information to the groups and then take action.
Yes, yes, absolutely. They are, the topics that they choose to pursue are the ones that those farmers are interested in and are more likely to take action on because it's something they care about.
Exactly. Okay, I'm looking at the time and I know that we're going to want to start wrapping things up. So I'm going to have you help us distill the whole topic down a little bit. And
Sure.
maybe the first thing I'll have you do, Sherry, is talk about, even if you've talked about it already, tell us why input reduction is really the first step to bringing down those phosphorus levels.
So this is great, actually, because it's something I do want to emphasize. I mentioned that agriculture, because it uses phosphorus regularly, every year, in fact, for most producers, it is something where we can see changes pretty quickly. As that phosphorus cycles through, gets added, gets removed by the crop, that means that every year you have a choice to be able to change this and to improve this. Um, so uh so that phosphorus, the input itself, if you for 1 year or 2 years did not reintroduce phosphorus via manure, via fertilizer, that would really quickly change the amount of phosphorus in the soil, in a conventional or in a no-till situation.
Okay. You also talked about legacy phosphorus, and I maybe missed it, but I don't know if there's a definition for legacy phosphorus, but I understand or I interpret it to mean that it's levels of phosphorus that are there and have been there on account of previous practices that may date back to, when grandpa was a little boy or longer. So we recognize that that is a relevant part of the whole phosphorus topic. Are there any specific ways that we can mitigate, I'll just say, damage that's already been done? Or is it really a matter of applying all the steps that one would use to prevent additional phosphorus stratification or an excess of phosphorus?
Yeah. So I do think that there's an opportunity here to say that legacy phosphorus, the definition can also include, by the way, phosphorus that exists in stream beds and stream banks. So we can see potentially levels of phosphorus that are higher in water bodies, not even because of what farmers are doing now or were even doing in the last 5 years, but because of what farmers were doing 10, 20, 30 years ago. When we're talking about sort of legacy phosphorus that is in a field, it's not necessarily literally the exact same phosphorus. Like you said, it's like high levels that continue because of what happened. Because even if you now are managing the field so that the inputs equal the outputs, you're starting at a higher level of phosphorus already. And especially in a no-till situation, um, you're getting that concentration right at the surface, and it can be difficult to bring that down over time. So that is why if you're dealing with a legacy phosphorus situation, you simply have to simply it's pretty clear that you have to reduce the inputs of what is going in, because then that legacy, the crops are going to start pulling on sort of that legacy phosphorus reservoir instead of the phosphorus that you're adding.
Okay. All right. So, Sherry, when it comes to cover crops specifically, what would be your recommendations to producers who really want to be keeping a close eye on their levels of phosphorus in the field? You talked about this in your presentation, and there were a couple of aha moments for me. There are different types of cover crops. So, talk to us about the take home messages when it comes to incorporating cover crops into our planting plans specific to reducing phosphorus stratification.
Absolutely. So I think the biggest consideration is that if you have excess phosphorus, then you need a plan for that cover crop that gets it off the field. Now, for some people, that might mean you could mob graze it. You know, if your cattle come and eat that grass and then they leave the field, the phosphorus has now left the field. If that's not an option, harvesting that and feeding it to your own cattle or feeding it to others' cattle, either way, you're getting that organic matter off of the field, and including the phosphorus that goes with it. When we're talking about dissolved phosphorus in particular, that is where I think this winter killed question, winter killed cover crop also comes into question. Dissolved phosphorus can be a fairly small portion of the phosphorus that we see lost every year. So if doing something like a tillage radish works best for your system for other reasons, I'm not saying don't ever do that, but do understand that, in the case that you get a freeze thaw event in winter or you get rain on frozen ground, because that tillage radish winter kills, it's going to release that phosphorus when you get those wintertime runoff events. And we can see a lot of phosphorus lost in one instance when that particular situation arises.
Excellent. And now I'm going to put you on the spot. I didn't prepare you for this, but if there
Okay.
was one take home message that you want our listeners to walk away with, what is the most important thing that you would want to share with them on this topic?
I think that the most important thing is that this might be an issue that you might not be aware of unless you are specifically testing for it. So consider including in your test regime, splitting off those top 1 to 2 inches from the rest of the column and getting those tested to see if you do have surface phosphorus concentrations above what the average would show you if you're just measuring 0 to 6.
Really good advice. And now I'm going to take the liberty to let all of our listeners know, whether they're listening live or they're listening to the recording, that because Sherry Schwert, our session presenter today, is an ag water quality outreach specialist with the UW Wisconsin Extension in Madison. That means she's available to help you and your organizations, your producer-led watersheds, to learn more about this. She's available to teach you more on your time and her time. Is that okay, Sherry?
Please, yes.
That's what Sherry is all about. And her name, title, and email address have been available on the screens throughout the session. But if you're listening, then you're not going to have seen that. So I'm going to spell it out for you. If you want to connect with Sherry on all questions phosphorus, water control, water quality, and phosphorus stratification, soil samples, and whatever you can think of, then you should email her. Her name is Sherry Schwert. Her email address is S as in Sherry, L, and then her last name, S as in Sam, C, H, W, E, R, T as in Tom, at WISC, wisc.edu. That's S.L. Schwert at wisc.edu. And if you'd rather call the PDP office and get her information, we have it too. We would be happy to share it with you. Sherry, I'm going to turn it back over to you for any last comments that you might like to make before I officially sign us off.
I mean, I hope everyone's planting season is going really well. I have farmers in my family, and it's always a challenge, but there's always opportunities for change every year, right? Thanks for having me.
Absolutely. Thank you, Sherry, for being with us today. And as a reminder, Sherry is an ag quality outreach specialist in the southwestern portion of the state, but there's a whole team of people like Sherry who can help you no matter where in Wisconsin you live. And I think that there might even be some ways to help those of our listeners in the boundary states who also tune in to the Dairy Signal. So we are going to be signing out from the Juneau PDP headquarters for today's episode of the Dairy Signal. Be sure to tune in again tomorrow. Bye.